Now let's move on to naming and determining formulas of ionic compounds formed from main group elements. Recall the main group elements are found on the far left and the far right of the periodic table. Here is a list of ionic compounds, ions, and their formulas. Please pause the tutorial and determine the naming pattern. Here is a list of questions to help you determine the pattern. Hopefully you've noted that for these ionic compounds, the first element in the formula was a metal and the second was a nonmetal. Also note that the metals form positive ions or cations, while the nonmetals form negative ions, also called anions. In order to name an ionic compound, first write the name of the metal, then write the name of the nonmetal. Let's try a practice problem. What is the correct name for the compound CaI2? The correct name is calcium iodide. Now let's look at how we can write the formula for an ionic compound. Why is calcium iodide, CaI2, not just CaI? Ionic compounds are electrically neutral, which means the overall positive charges on the cations in one formula unit must equal the overall negative charges on the anions in one formula unit. In other words, to obtain a neutral compound, the charges are balanced to form a net zero charge. Looking at the periodic table, we see that calcium is a metal in the second column from the left, indicating that the charge on the calcium ion is 2+. Similarly, iodide is a nonmetal located one column to the left of the noble gases, so the iodide ion has a 1 negative charge. Thus, to form an electrically neutral compound, we must have 2 iodide ions for each calcium ion. Let's work through a practice problem to figure out how to obtain a net zero charge. What is the correct formula for barium oxide? First, write the cation and anion for barium and oxide. Then, determine how many cations and anions are needed to produce a neutral compound. Since the 2+ cancels out 2 negative, the correct formula for barium oxide is BaO. It is incorrect to write this compound as Ba2O2 because chemical formulas of ionic compounds are always written as the lowest ratio of elements. It is unnecessary to include a subscript if the subscript is 1. Let's try another practice problem. Please pause the tutorial and determine the correct formula for aluminum sulfide. In order to determine the correct formula of aluminum sulfide, first write the cation and anion. Then, determine how many Al3+ and S2- ions need to be present to obtain a net zero charge. Notice that the lowest common multiple for the charge is 6. Therefore, multiply the Al3+ by 2 and the S2- by 3. By doing this, the charge is balanced. Here is a list of common anions, cations, and polyatomic ions. An ion that consists of 2 or more atoms is referred to as a polyatomic ion. Here are a few practice problems. Please pause the tutorial and figure out the correct formula for each compound. In order to determine the correct formula for magnesium nitrate, first write the cation, then write the anion. Then, determine how many magnesium ions and nitrate ions need to be present to obtain a net neutral charge. Let's try using trial and error to figure out the correct formula. Let's say there need to be 2 magnesium ions and 2 nitrate ions. This is not the correct answer because the net charge is not 0. Let's try 1 magnesium ion and 2 nitrate ions. This is the correct answer because there is a net 0 charge. Therefore, the formula for magnesium nitrate is Mg parenthesis NO3 parenthesis 2. If there are more than one polyatomic ion in a formula, we must put parentheses around it and put the subscript outside of the parentheses. If the parentheses were not used, the formula would be NO32. This is not the correct formula because it indicates that there are 32 oxygen atoms in the compound. Here are the correct answers for the rest of the problems. If there are more